See, today we'll start with the reluctance numerical based topic. So, in this we'll have two kinds of circuit. One is circuit and another magnetic circuit. In electric circuit, in magnetic circuit we'll use MMF. Electric circuit we are using resistance, but in magnetic circuit we are using reluctance. And reluctance is denoted by S. Resistance is basically opposes current, right? Resistance is it opposes the flow of current, but the reluctance is S, and it opposes magnetic flux, magnetic path to flux, and its unit is ampere on Weber. Clear? So we'll learn all the formulas. First of all, we should know the formula of reluctance, that is denoted by S. Write it down, equal to, and its formula is L divided by mu naught mu r divided by A. What is mu naught? Mu naught value is fixed, 4 pi into 10 raised to power minus 7, right? And that was given in the question, and A is the area, correct? And what is the unit of is ampere per Weber. This formula is very important. Sometimes they ask you to calculate reluctance of air gap. That case, mu r is always 1, is equal to 1 will be divided by mu multiplied by area. They can ask you to calculate MF. There are two formulas for MF. One is number of turns multiplied by current. The formula of MF is equal to multiplied by S. I is the flux, and mu is equal to multiplied by. Next, they can ask the flux formula. Flux is equal to multiplied by A, where phi is the magnetic flux and Bm the magnetic flux density, right? Flux unit is magnetic flux unit per meter square equal to 1 Tesla, right? And length, we sometime we need to calculate length also. Length formula is pi into d. What is d? D is the diameter or the normal diameter. Okay, basically length is the circumference. Length is circumference, and sometime they ask you to calculate H is equal to Ni by L. H is the magnetizing force, N is the number of turns, I is the current, and L is the length. I try to write down all the formulas in a single. Okay. See, I'll tell you. In this case, calculate, right? This phi in, right, and density resistance phi is sorry multiplied by, right? How much divided by r multiplied A and A out, and length is sorry, need to calculate, right? ST is distance 1 S the ring, the air gap, right? Have formula L by mu and L divided by area. Area we can, right? Length is how they said it's complete 100.2, and this the iron ring how much? 100 minus 0. 100 point minus 0.2 now. 0. How much? 5 into 10, 7. They didn't. What is 1000? What is 1000? A will remain area A only because we don't know. Again, 5 into 10 minus 7. Area is real. That's how area and area cancelled. Substitute mm. Yes or no? So calculate, and I'll tell you the of y for it is 5.58 and S air gap. You will get it as 591 point. See this is the, consider magnetic then air gap as core material has relative permeability 6000 means mu r is equal to 6000 rectangular area 2 by 3 centimeter. Okay. Rectangular cross section by 3. Coil has 500 is equal to 500. Determine the current supply current required to establish flux density B. That is they have given 5 Tesla, right, in the air gap. So basically, as I let us see I is here, right? In already given to n that is 500. Be able to get m then fault, right? And for mmf to get phi and s, right? Phi is basically have to use, right, mix and match. Then let question. So is first of all, whatever the case is there, we calculate reluctance, right? So calculate two reluctance. One is for the one the air gap. Whenever you get these, now you always need to get reluctance. Okay. So L is air gap is L divided by mu naught multiplied by area, and this would be L mu naught mu r multiplied by 8, that reluctance, right? 4 pi into 10 raised to 1, r is also given 6000, right? And give you the length also. They didn't give directly, you need to calculate the length, right?